Hello and welcome back. For this video we're going to identify some key features of parabolas or quadratic equations or functions, but from standard form. And here's a quick reminder of what the standard form or general form looks like: ax squared plus bx plus c, the same letters a, b, and c you need for the quadratic formula. And the first thing we're going to be able to find is the axis of symmetry. Now from this standard form, your axis of symmetry again is x equals, because it's a vertical line, the opposite of b, so the opposite of this number here, divided by 2 times the a value, which is this leading coefficient. And this should look familiar because this is actually part of the quadratic formula. Okay, so the next thing we'll find is the vertex. Now the vertex has to have the same value for x as the axis of symmetry. So whatever this number is, that goes right here for your x value. Now your y value can be determined by taking whatever this x is, substituting it back into your function here, and let it calculate or output some value. That's all we have, f of negative b over 2a. Now there is an alternative method you could use for the y coordinate. So this is another version of the y coordinate of the vertex, and it comes from taking the c value, which is up here, and subtracting from it b squared, so this b here squared, divided by 4a, so 4 times a. Now make sure in order of operations you do this calculation first before you subtract it from c. The y-intercept from this format is very easy because it's always the constant value. We also want to be able to determine if we have a minimum or maximum function, and this goes back to the same as being in the vertex form, the a value, which is this leading coefficient. If it's greater than 0, meaning it's positive, your curve will open like this, creating a minimum point right here at the vertex. And if a is less than 0, meaning it's a negative leading coefficient, your curve will open like this, creating a high point or maximum point in your vertex. Now if you want to know what the min or max value is, again, you got to go back to the vertex and find the y coordinate, because min and maxes are always output values. So we're going to use this example here. We're going to find these key features. We're also going to determine the domain and range of this, but we'll do that on a graph. And the first thing we're going to find is the axis of symmetry. And that's going to equal, as it says up here, the opposite of b. So b is negative 8, so the opposite of that is going to be positive 8, over 2 times the a value. So a is 2, 2 times 2 is 4. So my axis of symmetry is going to give us 2. So my line of reflection is going to be x equals 2. Now since we're finding the vertex, we already have half of the vertex, because remember this axis symmetry number has to be the x coordinate right here of your vertex. So your vertex is going to equal 2. And then what we're supposed to do is take this 2 and substitute it back into here, here, and here in output. But of course we're going to use this function here, or we could use this shortcut version. I'm going to substitute the 2 in first. So 2 times 2 squared, so this is where my x was, minus 8 times 2 plus 6. So follow the order of operations. 2 squared is 4. 4 times 2 is going to give us 8. Negative 8 times 2 is negative 16, and then plus 6. 8 minus 16 is going to give us negative 8. Negative 8 plus 6 is going to give us negative 2. So the vertex should be located at 2, negative 2. Now if we do this shortcut version, we'll take c, which is right here, 6, we're going to do 6 minus, and then we want to do b squared. So b is negative 8, but negative 8 squared is 64. And then a is 2, so 4 times 2 is 8. Remember, you got to do this calculation first. So we get 6 minus 8, which is going to give us exactly the same negative 2 we got by substitution. The y-intercept is always our constant value, so the y-int equals 6. And our leading coefficient here is a positive. So we are looking at a, leading coefficient is positive, we are looking at a minimum function. So this is a minimum. And the minimum value is going to be whatever your y-coordinate is of your vertex. So the minimum value here is negative 2. So we'll have a graph that looks something like this, where we have a minimum value right here at 2, negative 2. So the negative 2, which is this value here, is our minimum. So let's go ahead and sketch this. Okay, so we're going to graph the vertex first, which is 2, -2, so over 2, down 2. So there's our vertex. Now we're going to pick a point to the right of this, so I'm at 2, so I'm going to pick a 3. So in a table of values, I have x and I have f of x. So I'm going to put a 3 in place of my x-coordinate, so I'm going to have 2 times 3 squared minus 8 times 3 plus 6. And then evaluate this out to give you my output for 3. So 3 squared is 9. 9 times 2 is 18. Negative 8 times 3 is negative 24. And then I have a plus 6. 18 minus 24 right here is going to give you negative 6 plus 6. And it turns out that this is actually going to cross at 0. So actually that's one of my roots. It's one of my solutions. So I have 3, 0. And now since we have an axis of symmetry which goes like this, if this is one of my points, the other point is going to be reflected right here. So there's my other solution. So 1 and 3 are my two solutions. I'm going to go and do one more point. So I'm going to put a 4 in. So I'm going to evaluate this at 4. So 2 times 4 squared minus, this was negative 8, or minus 8 times 4, and plus 6. So 4 squared is 16 times 2 is 32. Negative 8 times 4 is negative 32 plus 6. So these two cancel each other out, leaving an output of 6. So we input 4, we output 6. So we go over 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. And since my point is 2 units away from my axis of symmetry, the other point can be reflected over here, which is the y-intercept, and that was expected because my y-intercept had a constant value of 6. So we'll just eyeball our curve here. Now if you want to find the domain, of course the domain here is going to equal negative infinity is less than x is less than positive infinity. Infinitely right, infinitely left, that's what that means. But the range though has a starting value down here at -2. So notice this number -2 comes up a couple times. This is my minimum value of my function. So my minimum value is -2 and less than or equal to the y values, because y is range. And this goes infinitely up, so we're going to say less than positive infinity. And this is our domain and range.